Hi everyone, my name is Petrovska. I'm here today with Patricia Goldberg and we'll give a short presentation on our accepted paper, Mining Gender Bias, a preliminary study on implicit biases and gender identity in the Department of Computer Science at the Technical University of Munich. Unconscious bias has been identified as one of the main reasons for poor gender balance representation in the IT working environments. Concretely, around 20% of the computer science degrees worldwide are awarded to women. The numbers in our department look as following: 19% of the students, 15% of the PhD candidates, and 11% of the professors are female. Understanding the reasons for the immense gender gap and the disproportion in the numbers of our department has been the core motivation for our work. Mining the gender gap and the biases should potentially lead towards identifying the reasons behind the numbers, which should later enable us to take proactive measures for improving the current situation. The problem that this work is tackling, it's twofold. The first problem was the creation of a questionnaire that could collect information on the person's hidden biases, which could be later analyzed. And the second is a technical problem for which we needed to create an online survey form that does not only collect the answers, but also collects the time for the respondents that the respondents took for answering the specific question and the number of errors that the respondent make while answering a question, which is an important information for one type of the questions that we have. The solution is proposing an online questionnaire which can gather data from both implicit and explicit questionnaires, and the contribution is a study focusing on measuring the computer science, gender stereotypes, and hidden biases based on the collected data from implicit and explicit questions. We have developed two types of questions: the explicit or self-reporting questions, contributing of three subgroups: questions on gender identity, quality ranking, and department. I will be talking briefly about all of them in a moment. And the second type of question is the implicit questions based on implicit association test, EIT. The first type of explicit questions were the gender identity questions, and the goal of this type of question was extracting the information about the gender identity of the respondents. We had 8 statements with positive and negative tone, and the answers were according to the 4-point Likert scale: strongly agree, agree, disagree, and strongly disagree. Now I will read a few of the statements that our female respondents needed to answer. For example, I feel I fit in with other females in my department. I feel comfortable being a female in my department. I feel that my personality is similar to most female personalities in my department. The questions with negative tones were, for example, I feel annoyed that I'm supposed to do some things just because I'm a female, or I feel people interpret my behavior based on my gender. The second type of explicit questions were the quality ranking, and the goal was to understand what qualities do the respondents think are necessary for successful studies and career in computer science. The respondents were asked to rank the 10 different qualities, characteristics, also shown on this slide, and this was a drag and drop question. Finally, the third type of explicit questions, department-related questions. The goal was to comprehend the student perception of the department, gender equality issues. Here we had 8 statements, again, according to 4-point Likert scale, plus not applicable option for the students that didn't have any supervisor or advisor yet. And some of the statements were the following: students in my department are treated equally by the staff regardless of their gender. I have witnessed gender discrimination from the staff in my department. I feel my supervisor advisor helps me identify my training development needs, or I feel that my supervisor advisor shows interest in my progress, success. Previous work has shown that in principle, the results from explicit questions tend to be misleading, since the respondents are often dishonest while answering the questions. Therefore, we introduced implicit questions based on EIT. In our work, we focus on 2 categories: art and computer science, and 2 targets, males and females. For each category target, 5 words were chosen as representative, and the respondents were asked to associate each word to the corresponding category or target. We collected the time and the numbers and the number of errors a person did. The EIT developed was divided into 7 association tasks, split into 5 steps. Step 1, 2, and 4 were a practice session, and the final hidden bias calculation was based only on the results from steps 3 and 5, disregarding the practice tasks.
So a bit about the presentation. So here we are tackling the technical problem that we had. For that, we developed an online source survey tool in which we collect the answers of each respondent and also the time and the errors that they did. For that, we use the technologies React in the front end, Python in the back end, Mongo as the database, and everything in a Docker container. The data collection we did from both bachelor's and master degrees level with 457 students, in which 41 were females, 58 were males, and 1% responded rather not say. The results. So first we had two hypotheses. The first one is that in the explicit questions, female and male students in our department give similar answers to the same question. The second hypothesis is in the implicit questions, each gender associated computer science easier with their own gender. And the first gender identity explicit questions we had in here separated by positive tone questions and negative tone questions. And in both of them, it supports our hypothesis that the males and female students had similar answer to each questions. And we can see in the positive tone question, we have more relevant, strongly agree and agree answers. And in the negative questions, we had more relevant disagree and strongly disagree response. So in the quality ranking, this is the answer for the first place of each word in percentage by gender. And we can see words such as emotionalist and strong, that the female gender responded twice as much as the male responded on such a word. So this can say that the answer from females and males students differed a bit on these type of questions. For the department related questions, we had 8 questions in here separated from male, female, and rather not say. And we can see in questions 3, 6, 7, and 8, they had more than 50% of not applicable of answers. I would focus a bit on question 3, which was about gender discrimination. And this is highly relevant that it's not applicable or disagree. And this might lead to the conclusion that this question was not well developed. For the implicit questions, we had winner in the end. So the winner is if the respondent associated easier female or male with computer science in degrees. So from little to none or too strong. In here we say classification. In here we can see that this plot supports our hypothesis 2, which is that each gender associated their own gender with the computer science. We can see male respondent, so the gender male, it's more strongly associated, but female as well associate female easier with computer science than male with computer science. Another way of analyzing these questions is by time, so on the left, the duration, and also by mistakes, so on the right. This is interesting that this is only step 3 and 5, which is the one that used to calculate the final results. And in step 5, which was associating female with computer science, the male students took more time than the female students. On the box plot on the right, so about mistakes, you can see that the females had a mean average similar through the steps, but male did more mistakes on the step 5. So our conclusion is that we had set up 2 hypotheses and our results supported. On the explicit questions show there's no significant difference in responses among females and male responded on the gender identity and department related questions. Nevertheless, it differed on the quality ranking where female students ranked characteristics usually linked to the opposite gender, such as emotionalist and strong, as more important to success in their studies and career. And the implicit association test results, we showed that the majority of female students in our department associated computer science with female easier than with male. And this represents 67% of our male respondents associated male with computer science strongly than with the female. In summary, you can see a correlation of the respondent gender with the hidden bias result, but this does not have enough data to conclude causality. As the next step, we continue collecting and analyzing data from the department that should enable better statistics and draw better conclusions.
Thank you very much for your attention.
Thank you.